So, hello everyone. Let's start with a new topic, fresh topic, which is graph. So, this is a starting lecture. So, first we will talk about what are the terminologies, basically terms we can say, which are used in graph. So, first of all, we will know about what is vertices slash edges in graph. After that, we will talk about undirected undirected slash directed graph. After that, we will talk about connected components. And next part will be, we can say strongly connected components. And last, we will talk about what is height. Actually, this is one of the question, height of the tree. So we will deal about later. Now, what is child? It is similar to tree, child, parent, leaf node, leaf nodes, and at last LCA. LCA means lowest. Uh, LCA, which is lowest common ancestor. Lowest common ancestors. Okay, so let's talk about first of all vertex. What is vertex and edges? Vertices. So in vertices slash edges. So if we say this is a graph, so first of all, we know the difference. What is the difference between graph and tree? So basically our graph, uh, it contains loop. It contains loop. Okay. While in tree, it does not contain any loop. Contain any loop. Okay. Simple. So tree is basically this. It does not contain any cycle. Okay. While graph, there is a loop. Okay, so if we connect this loop, this is a loop. Okay, so suppose let's talk about some big tree. Suppose this, so now it is connected, so it is a loop. And it it all the all the nodes are connected with each other. Okay, so this is a kind of graph, and this is a tree. Okay, so let's talk about what is vertices. Vertices is nothing but the total number of nodes. Okay, and edges is this one. These are the edges, and these are the vertices slash nodes we can say. Okay, now we will talk about undirected and directed. What are what this term means? So undirected slash directed. So basically undirected means the graph which does not contain any direction. So if if we give numbering to these nodes, let me draw it clearly. 1, 2, 3. Okay, so we can travel in both the direction. We can come from 1 to 2 and we go back from 2 to 1. Okay, similar here go we can go from 2 to 3 and 3 to 2. Similar 3 to 1, 1 to 3. Okay, so we can go forward as well as backward direction. Okay, in case of directional nodes, and let me rub this. In case of directed graph, so if we draw a directed graph, 2 and this one is 3, so directed graph look like it contains arrow. Okay, it contains arrow, so we can go from 1 to 2, but we can't go from 2 to 1. Okay, similarly we can go from 2 to 3, but we can't go to 3 to 2. It's basically if the we can say if the point if the arrow is pointing towards that node, we can go from that node to that node. If our pointer is if our pointing arrow will be reversed, so we can go from 3 to 2, not 2 to 3. Okay, so it's simple. Okay, so this is our directed graph. Now we will talk about what is another one, connected component. Yep. So what is connected component? Connected component. So basically connected component is nothing but if we can go from one node to two node to three node to four node, which is basically I can say I can reach 3. I can reach 3 from any of the node, from 1, from 2. Okay, this is, or there should be one more thing, but we can't reach 4. Okay, because this is a different component. So this is our graph, but it is not connected with any of the nodes from this component. So we can say there are two connected components. First one is this one, and second one is this one. Okay, now we will talk about strongly connected components. Strongly strongly connected components, which means we can this is basically which we can reach. So basically we can say there is a path from each vertex to another vertex. So how can we draw this? Let me draw this. How it's strongly connected components look like. Let me rub this. Again we will draw. This is 1, this is 3, this is 2, this is suppose 4, this is something like 7, 6, 7, 5, 6. Okay, and another one is 8, suppose. So we can make a node from this to this, and after this. Okay, so this is one part. After that, we combine with another part. So this looks like this, and this looks like this part, and so this. So how can we determine connected component? So the definition of strongly connected component is there is a path, and there should be a path for each vertices to another vertex. Means if we are standing on the node 1, let me if we are standing on the node 1, we can reach 2, we can reach 3, we can reach 4. Okay, if we are standing at 3, suppose, let me draw it. If we are standing at 3, we can reach 4, we can reach 2, we can reach 1. Okay, so this is a strongly connected components. Okay, but we can't reach, suppose, let me make an arrow, but we can't reach from 3 to 5. So this is not strongly connected. We can't reach, if we are standing on node 3, we can't reach 5. So this is let me so this what's the problem. So we can, this is another strongly component, this is another strongly component. We can reach 5 from, 6 or 7. Okay, similarly. So there are three strongly connected components. There are strongly connected component. Okay, another term is, what is another term? Uh, Child parent leaf node. It is similar to the tree. Let me revise again. What do you mean by child? If this is our tree, uh, not tree, this is our graph. 1, 2, 3, 4, and 5. Okay. So if we want, this is our leaf node, because there is, this is not leaf node. This is our leaf node, because it does not have any child. Okay. So it is a leaf node. What is parent? This is a parent node. Okay. So simple. It is similar as tree. Now we will talk about LCA, lowest common ancestor. LCA, which is lowest common ancestor. Okay. So lowest common ancestor. What do you mean by lowest common ancestor? If we make a graph, let me make a graph. 1, 2, 3. It is 4. It is 5. It is 6. It is 7. Okay. So if we have to find lowest common ancestor of 6 and 4, so n- we can, basically we have to find the parent node, which combines both the nodes. Okay, so if we come back, we will find 3. If we come back, we will find that 3 is parent of both the childs. Okay, so we can compute from this that LCA of 4 and 6 is 3, not 5, because 5 is not connected with 4. Okay, 5 is not connected with 4, so uh, we can't put our answer to 5 in LC. Okay, so the lowest common ancestor, which comes first, the parent which comes first, which belongs to both of the child. Okay, so let's take another example. If we want to calculate the child of, let's say, 7 and 6, so what is the first parent which combines both the nodes? Okay, so let's see. So now we have to compute the uh, lowest common ancestor of 7 and 6. So how we can find? So basically we see that 5, whether it is connected with 7 or not. Nope, it is not connected. Again we go back. 3, it is connected with 6. 7, no. We basically we have to travel both sides. So 2 is connected with 6, nope. If we go 1, yep, it is connected to both of our child. Basically 1 is connected with 7, and 1 is connected with 6 also. So this is how we can find. Basically it's like a family relation. Okay, so it is very similar to the family relation. We have to find our grandfather. Basically, yeah, we have to find our grandfather from our family tree. It is family tree. Simple. Okay, so this is all about the what are the terminologies which are used in tree, graph, sorry. So thank you. Let's have a nice day.